Well, let's continue with our discussion of decoding Gӧdel numbers. This is part 2 of this mini-series. So let's get back to the problem of obtaining the number of the source code. So now we have the factors, just state the obvious. Yes, that factors of n and I that we covered in the previous screencast is a primitive recursive function, and we can easily show it. Well, there'll be some work, but we can use theorem 5.4 in chapter 3 of Davis, Waker, and Segal's book, second edition. And this is the definition of cases, a definition by cases. So, okay. Now, n. Let's suppose that n is the number of the program. That's this Gӧdel number, where the compiled instruction numbers are prime powers. So -1. So then n, the source code, number is n plus 1. And once we have n plus 1, we can apply factors to that number, factors of n plus 1, and this gives us the list of prime factors of the source code. Oops, I made a mistake. It's n plus 1. Let me grab an eraser, erase this. It's not n, it's n plus 1, because we're factoring the source code number. Okay, this one. So list of prime factors, okay, n plus 1, and from the list of prime factors, we can actually obtain the Gӧdel number. Okay, because once we have the prime factors, we can compute the prime powers, the powers of each factor, and that's exactly what we want. Then we can get the source code, source code number. The Gӧdel number with the prime powers. So here's a let's go through a couple of examples. So suppose that the number of the program is 7. So that means that the source code number is 8. 7 plus 1. So, but we still have to get to the individual instructions, and so we have to factor it out. So factoring 8 gives us the list of 222. This is not a Gӧdel number, it's just a list. Now, but from this list, we can simply count the number of times each factor is used, and we know that the Gӧdel number is equal to 3. So what does that mean? It means that 7 encodes an L program with 1 instruction, and that instruction compiles to number 3. So the program P consists of 1 instruction, and that instruction number is 3. Okay, this is 3. Okay, let the number of the program be equal to 13. Then the source code number is the number of the program number plus 1. It's 14. So we have to get to the individual instructions. So factors of 14 and 1 gives us the prime factorization, 2 and 7. This is not a Gӧdel number. This is just prime factors. So, but the Gӧdel number corresponding to the prime factorization is actually 1001. 1. Okay, this is the power of the first prime, and 7 is prime number 4. So 100, prime number 3 and 2 and 3 are used 0 times. So their prime powers are 0, right? 3 and 5. So P has 4 instructions, and the number of the first instruction is 1, the number of the second instruction is 0, the number of the third instruction is 0, and the number of the fourth instruction is 1. So P has, remember we talked about the length of the natural number, so the length of 14 is 4, right? So the length of the program, P in this case, is 4. It means there are 4 instructions, and these are these numbers. The prime powers encode their numbers. Okay, so how do we decode instructions? So let G be the Gӧdel number. That has the numbers of P's instructions. So once we know those numbers, we can go ahead and decode each individual number to obtain from that number the source code of each instruction. So, and we know that if the number of the instruction is Q, that Q is the pair whose first element is A, and whose second element is another pair on B and C. You can review the screencasts and the lectures on coding programs with Gӧdel numbers, where we talked about pairing functions. So A is the left component of Q, so it's L of Q. And if A is 0, then the instruction I is unlabeled. And if A is not 0, then A essentially encodes the number of the label to the left of that instruction. In the label ordering. Okay, now recall that B, which is L of R of Q, so we get the right element of Q, which is BC, and then we get the left element of that right element, which is B. Then if B is 0, B encodes the instruction type, then I is of the type V arrow V, so it's a self-assignment and no op. If B is 1, then I is addition. It's of type V arrow V plus 1. And if B is 2, then I is of the type V arrow v minus 1. Okay, so subtraction. Otherwise, if b is greater than 2, that means that by our coding scheme or compilation, we must be dealing with the dispatch, conditional dispatch. So I must be of the type if v is not equal to 0, then go to L, where L is some label, and the number of that label, if you review our coding screencasts, coding programs with Gӧdel Numbers, and also the PDF lectures, its L's position is b minus 2. So, and what about C? So C, it's R of RQ, right of I, right of Q, which is BC, and right of that gives us C. Then, and that C encodes the variable used in the instruction I, and the number of that variable is C plus 1, so it's C plus first variable in the label ordering. Let's work out an example. So suppose that the number of the compiled program is 199. So what is the source code of the program? So we're reverse compiling it. So source code number, right, that's the first step, is 199 plus 1. Okay. Now we have to go and compute the Gӧdel number corresponding to the prime factorization of 200 to get to the numbers of individual instructions, and then once we have the numbers of individual instructions, we can actually go ahead and extract the source code from each of those numbers. So the prime factorization of 200 is 22255. So 2 to the third times 5 to the second. So the G number is 302. Right? So 3 times the factor of 2 is used, so 2 to the third. 0 times the factor of 3 is used, and the second prime, and then 5 is used, which is the third prime. 5 is used twice. So 2 to the third times 3 to the 0 times 5 to the second. So 3 is the number of the compiled, corresponding to compiled first instruction, though 0 is the number of the compiled second instruction, and 2 is the number of the compiled third instruction. So we have those natural numbers. Now we can actually use the pairing function to decode them. So 3 is equal to the pair of 2 and the pair of 0, 0. 2 is the number of the label, which is B1 in our label ordering, and then 0 is the variable number, so that means that the variable is y. It's C plus 1, that's the first variable is y, and 0 is the number of this no-op operation, y arrow y. Okay, so what's the pair corresponding to 0? That's 0 and the pair of 0. That means that the instruction is unlabeled y arrow y. And then finally we have 2, which is the third element in the G number. Okay, and 2 is equal to the pair of 0 and the pair of 1 and 0. So that means that this is the addition. The instruction is this, y arrow y plus 1. So the source code of the program that we just reversely compiled or decoded is instruction number 1, corresponding to number 3 is labeled with B1, y arrow y, then y arrow y. The second instruction unlabeled, and then the third is y arrow y plus 1. So this is the source code of this program compiled to number 199. So to be continued.